हेलो। आ, चलो यार, एक कोई बढ़िया क्वेश्चन देखते हैं। जो चीज़ें अपन ने नहीं पढ़ा है वो भी देख लेते एक करके। तो कहाँ पे मिलेगा? यहाँ पे ना। थोड़ा सा। हाँ, मैंने स्क्रीन शेयर किया है क्या? नहीं किया होगा शायद। कर देता हूँ। एंटायर स्क्रीन चेक 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 कर दिया मैंने। स्क्रीन में शेयर।
is equal to summation of say I equal to 1 to n residue of x of z into z raised to k minus 1 at pole pi. What does it mean? So for example, denominator of a system has n roots. That means system has n poles, or function has n poles. So for every pole, we have to find out the residue. And if there are n poles, then the summation of all residues will be x of k. So this I equal to
because they're saying
1 to n holds true only if there are distinct roots. If the roots are not distinct, there are some repeated poles. So this number will differ, n will differ. The poles will be n, but the residues will not be n. Because even though there is repeated pole, the residue is only 1. So how to calculate the residue of x of z into z raised to k minus 1 at pole pi? Let us call residue equal to r. So let me call it for distinct poles. Let me call this as ri. Ri means residue for ith pole. That is equal to, say, residue of x of z into z raised to k minus 1 at pole z is equal to pi. So fine. And it is equal to limit z tends to pi, z minus pi.
again, your Ri residue is equal to a residue of x of z per k minus 1 at poles z equal to pi. अच्छा अच्छा अच्छा, ठीक है ठीक है ठीक है।
Into x of z, z raised to k minus 1. So this is what? This is the residue of x of z into z raised to k minus 1 at pole p equal to pi. And now
सही बात
there are repeated roots.
है। रेशियो का सबमिट करते हैं। लिमिट z tends to pi z minus pi x of z z to the power k minus 1। ये अपना पूरा टर्म है। ओके, चलो ये वाला बोर्ड भी ले ही लेते हैं। व्हाइट बोर्ड है अपना। और ये रहा अपना बोर्ड। इसको यहाँ से जाएंगे। What? So today we have, I think, is today Bind versus PHC कब था? क्या वो कल है? Bind versus PHC कल है यार वो तो। एंड आर्सेनल वर्सेस एटलेटिको आज हो चुका है क्या? बहुत पहले आते हैं यार ये नोटिफिकेशन। 12:30 अभी तो शायद खत्म हो गया होगा। ये जस्ट होगा खत्म, इन मोमेंट्स होगा। I just don't want this Atletico to qualify by any chance। वो क्वालिफाई हो जाएंगे ना, बहुत ही घटिया लगेगा मुझे एकदम। सालों ने बार्सिलोना को निकाल दिया। अरे यार कुछ भी नहीं लगी मेरे को। क्या हुआ? Is it win or lose? कुछ भी लाइफ कैसे नहीं आ रहा? तो नहीं होना चाहिए। अच्छा खत्म हो गया मैच, खत्म हो गया, खत्म हो गया, खत्म हो गया। स्कोर चेक करता हूँ जल्दी से। आर्सेनल Arsenal won it. I'm so fucking happy. I'm so fucking happy भाई। बहुत खुश हो गया मैं तो ये देख के। डेविड Griezmann played really well today. Doesn't matter. They lost and that's it. तो अच्छा आज में फाइनल खेल रही है यार फिर तो। ग्रेट। What keeps on happening? Why are these guys saying congratulations and all of this? हुआ क्या है?
So he's not. So he's not my intern anymore. वो निहारिका के अंडर इंटर्नशिप करना चाहता है, मतलब क्या? मेरे लिए तो अच्छा ये जाके उससे फ्लर्ट करे, मुझे क्या? पर वो आई थी मेरे पास अपने बर्थडे का इनवाइट देने और कह रही थी कि आयुषी तू पागल है जो दोनों से बिहेवियर में वन रेट किया। सच है क्यूट फन लविंग गाय कुत्ती। उससे ये नील आके वेरी कैजुअली कह रहा है कि हाय गुड मॉर्निंग, जैसे कुछ हुआ ही नहीं। तो मैंने भी कह दिया कि तुमसे रिजेक्शन बर्दाश्त नहीं हुई ना, इसलिए तुमने टीम चेंज कहा। हंसने लग गया यार, इतने करीब आए थे, इतने करीब। मतलब क्या है? तो कहता मैंने तो रिजेक्शन एक्सेप्ट कर ली है, पर आप कैसे एक्सेप्ट करोगे कि मैंने रिजेक्शन एक्सेप्ट करके मूव ऑन भी करना शुरू कर दिया है? हाँ तुम्हारा वहम है ये, मैं तो बहुत खुश हूँ कि तुम्हारी शक्ल नहीं देखनी पड़ेगी। तो कहता अच्छा फिर कल निहारिका मैम की बर्थडे पार्टी में मत आइएगा। क्यों नहीं आऊंगी? क्योंकि मैं भी आऊंगा वहाँ। आई डोंट थिंक आपको मेरी और मेरी +1 की शक्ल देखकर अच्छा लगेगा। +1 so he is not my intern. उसने बुलाया इसलिए नहीं गई थी, मुझे कुछ क्लियर करना था इसलिए गई थी, ताकि मंडे से वो अपने रास्ते और मैं अपने क्या बिंदी क्यों घूर रहे हो मेरी?
अच्छी लग रही थी इसलिए लगाई, ज़्यादा दिमाग मत लगाओ। तो मैंने उसे सामने से आते हुए देखा की तरह हाथ में आधा घंटा लेट आया था। क्या था? फ्लावर्स फॉर यू। ये ना मैंने खुद बनाया है ताकि ये हमेशा आपकी तरह खिला हुआ रहे। मैंने एक बार क्यों बनाया है तो कहता है तुम ना अपना ये फेक एटीट्यूड बस एक दिन के लिए छोड़ दो प्लीज, बस एक दिन के लिए। मैं कहा यार तुम्हें जो भी बात करनी है जल्दी कर लो, मुझे जाना है। तो कहता हाँ बात में जल्दी कर लेता हूँ, मुझे बस ये कहना है दैट आई लाइक यू। So he is not my inter. I like you. बोल रही हो उसने? I was like 4 दिन हुए हमें मिले हुए, तुम जानते क्या मेरे बारे में जो you like me? तो कहता 4 दिन हो गए आयुष्य में मिले हुए। I mean I like you from the moment I saw you. Remember close ring? यार देखो मुझे पता था कि ये लड़का आज कोई बकवास करेगा, बट प्रपोजल नहीं, दिस इज गोइंग टू फार। मैं इतना घबरा गई, मैंने उठाया अपना बैग और बोला देखो आई एम नॉट इंटरेस्टेड इन यू एंड इन ऑल ऑफ दिस ड्रामा, आई एम लीविंग बाय। तो कहता ओके ओके नहीं ओके, देखो मुझे कोई फर्क नहीं पड़ता है, पर अभी इस लड़की ने मुझे बोला आई लाइक यू, अब ये रोकेगा भी नहीं। तो कहता एक्चुअली थैंक यू सो मच फॉर कमिंग, इट रियली मीन्स अ लॉट टू मी। आप आए, आपने मेरे मन की बात सुनी, बट अगर आप इंटरेस्टेड नहीं हो ना तो मंडे से आई बी योर रेगुलर इंटर्न। कूल? क्या कूल यार? आई वाज लाइक नील तुम हो क्या? तुम जब से आए हो तुमने मेरा जीवन खराब कर दिया है। तो कहता बस इतनी सी प्रॉब्लम, ये प्रॉब्लम तो कल ऑफिस में मैं सॉल्व कर दूंगा पक्का। नाउ जस्ट गो एंड रिलैक्स, बाय बाय, टेक केयर। सो ही इज नॉट याद भी कभी।
Okay, so let's talk about this idea formally. What this says is that so क्या कह रहा है कि रेसिड्यू ऑफ आर आई इज रेसिड्यू ऑफ बेसिकली तुम इसका रेसिड्यू निकाल रहे हो एट सम पोल पी आई। इसका रेसिड्यू निकलेगा कैसे? आर आई शुड बी गिवन बाय सेट माइनस पी आई एक्स सेट into set key minus 1, and then you should evaluate this thing at z equal to pi. So it is like more formally, if I want to write it, it will be limit z tends to pi set minus pi x z z to the power k minus 1. Yeah, that's it.
I'm directly for each of I will find this R. So let here also we have to see for different poles of what? X of z into z raised to k minus 1. Even here repeated poles of what? X of z into z raised to k minus 1. Repeated poles of this. So let how many poles? Let us consider one case that there are n repeated poles. Say n repeated poles. For example, 1 upon z plus 1 raised to n. That means n repeated poles at z equal to minus 1. This is the case. So in that case, this residue is given by 1 upon n minus 1 factorial limit z tends to pi. This is the pole. Derivative. How many derivative? N minus 1 derivative. Of what? Of z minus pi. That is the repeated pole raised to n into x of z raised to minus k. So k minus z raised to k minus 1. So what is that? We can say for example.
Yeah, so I think there's a way. Like if something like this, that let's say if you have 1 by side plus 2 whole cube, so try to find for let's say the first one. It is basically like the residue for that plus 2 whole cube. You don't do one single derivative, right? So therefore it is said that dn minus 1. So if your n is equal to got it.
Root at 1 upon z raised to 1. Or say let us consider one case. Let the poles are at let x of z is equal to 1 upon z plus 1 raised to n. Then residue of x of z raised to k minus 1 at z equal to minus 1 is r is equal to, how many repeat terms are there? N. So this will be 1 upon n minus 1 factorial limit z tends to, this pi is what? Minus 1. Z tends to minus 1 into n minus 1 derivative of z plus 1 raised to n into x of z. What is x of z? That will write. So this is 1 upon n minus 1, 1 upon n minus 1 factorial limit z.
It's a very general idea. Like, if you want to find for, let's say, if you have 1 by z plus 1 square and you're trying to find the residue at z equal to minus 1, right? So what you would do is you would do dz of the residue that you got. Like once you would do, right? If you had, let's say, z plus 2 cube, so you would do d2. Basically, it is always n minus 1 and dz n minus 1. So they are also coming up with the same idea that it is nothing but dn minus 1 dz n minus 1, and then as your pole is at minus 1, so it is nothing but z plus 1 to the power n x of z, right? X of z, z to the power k minus 1 is also included, right? So, and you divide this by 1 by n minus 1 factorial, right? So it's a very general way of doing it.
It tends to minus 1. So for the sake, what we will do, we will have some other pole also. Let z plus 2 into n minus 1 derivative of.
You try to do it in a copy itself because it's causing a lot of problems. Because this board needs to be actually brought down every time, so that's a problem.
This z plus 1 raised to n, z plus 1 raised to n gets cancelled. 1 upon z plus 2, z raised to k minus 1. So in this case, what we need to do is, we have to take n minus 1 derivative of this entire, and then give it z equal to minus 1. That will be the ratio. And if you want to get the ratio at z equal to minus 2, in the same example, residue of x of z raised to k minus 1 at z equal to minus 2 is that r is equal to, it is a distinct group, so we come here. So it will be limit z tends to pi, pi means 4 at minus 2, z plus 2 into, what is x of z? 1 upon z plus 1 limit z tends to minus 2, this z plus 2 gets cancelled. And of this concept, let us solve some examples. We will solve the above examples. Of inverse z transform of x of z equal to z into z plus 2 upon z plus 1 into z plus 3 by residue.
Okay, let's see this difference equation thing. That would make more sense.
Zero Education Society. Redefining excellence.
Welcome back. In the previous 5 to 6 classes, we have seen Z transform and inverse Z transform. Now let us come to its important application in the analysis of discrete time control system, that is solution of difference equation. Now what is difference equation? Difference equation is the equation relating input and output of the system, and it is given as, or any discrete time LTI system can be represented as, we will see it, any discrete time, linear time invariant system can be represented as summation I equal to 0 to n y of k minus I is equal to summation I equal to 0 to n u of k minus I, where y is the output of system and u is input applied to the system. And here this difference equation is expressed in terms of delays. Like say this is nothing but this can be expanded as say y of k 12. We will give here coefficients.
So what they're saying is you can always represent this as equal to some u, and this will go like from k minus I, and this will be k minus I as well. Yeah, I is from 0 to n here, and just from 0 to m here, dependent on the number of inputs in the
ai, and here the coefficients be I. So this is nothing but a0 y of k plus a1 y of k minus 1 so on up to an y of k minus n, and it is equated to b0 u of k plus b1 u of k minus 1 so on up to bm u of k minus m, and where m is always less than equal to n for the cosine. Now this difference equation is represented using delay versions of input and output. Same way we can represent it as or summation I equal to 0 to n ai y of k plus I equal to summation I equal to 0 to m di u of k plus I with again m less than equal to m. So a discrete time system will with a linear time variant, it must be discrete time LTI system can be represented in this form or this form. Now in this case u is known and our interest is in finding out y for the applied u. So how to do it? Now solution of this difference equation is y of k, which is a system output. So So what we want to find is solution of differential equation using Z transform. So how to do it? What we will do? I will say general procedure. To solve differential equation, and this is linear differential equation. That is why we can apply Z transform. Step number 1.
The procedure in general should probably try to take Z transform of this, Z transform of this, and solve it, right?
Apply Z transform on both sides of difference equation.
I need to figure out why are these guys telling congratulations to each other. What did they do? अभी तक समझ नहीं आया किया क्या है इन लोगों ने. किया है.
So if I apply Z transform on both sides, what I will get? I will get a terms in the form of y of z and u of z. Then for the known input u of k, find u of z, and then